Today, we are going to be talking about Java recursions. Recursions can be confusing at times, so hopefully this video will help clear things up a bit. So recursion is when a method calls itself. And it is most useful when it's being used to solve problems where the structure of the problem repeats. Alright, let's look at the first example of a Java recursion. This public method neverEnd will print out this is the method that never ends, and call itself, print out the message, call itself again, and so on. So this is called an infinite recursion, which is a recursion that never ends. So what we need is a base case, which is a thing that stops the recursive method from calling itself. Now let's look at an example of a method called factorial. What happens when we call factorial of 0 is that it will go inside the method and then check if 0 is equal to 0. It is, so it moves on to line 4 and returns 1. And that was simple because it didn't even reach the recursive call yet, which is on line 6. So what happens when we call factorial of 1? It will check if 1 is equal to 0. It isn't, so it returns 1 times factorial of 0. We already know that factorial of 0 returns 1. 1 times 1 is 1, so factorial of 1 also returns 1. Now let's look at a more complicated example by calling factorial of 4. Factorial of 4 returns 4 times factorial of 4 minus 1, which is factorial of 3. Factorial of 3 then returns 3 times factorial of 2, so it keeps going until it reaches factorial of 0, which we know is 1. And in this example is the base case, so it stops the recursive method. We know that factorial of 1 is 1, factorial of 2 is 2 times factorial of 1. Substitute in 1 for factorial of 1 and we get 2. Same thing for factorial of 3. Eventually we reach factorial of 4 and the answer is 24. Something to keep in mind is that execution of the current method pauses while the recursive method is being processed. So let's take a more detailed look at the previous problem. Recursion is a lot like cup stacking. You start from factorial of 0, or in this case the bottom cup, or base case. You keep stacking until you reach the top cup, or the most current execution, factorial of 4. Factorial of 4 is equal to 4 times factorial of 3. You know what factorial of 3 is because it is the cup beneath factorial of 4, so you can substitute the value of factorial of 3 into the return statement for factorial of 4. Remember that factorial of 4 executes last because it pauses while factorial of 3 processes, and then factorial of 3 pauses while factorial of 2 processes. So basically all of the method calls are paused until you reach factorial of 0, which returns 1. Let's look at another example that is a bit more complex. Let's say you call mystery of 1234. This would be the order in which it is run. Don't worry if you are a little confused because it's a bit more complicated than the factorial method. You enter the method, and the first thing you do is print out the remainder of 1234 divided by 10, which is 4. Then you see if 1234 is divisible by 10. It's not, so we go on to the next line. Inside the if body is the recursive call, and it calls mystery of 1234 divided by 10, which is 123. Keep doing this until you reach mystery of 1. Mystery of 1 does not go into the if statement, goes to the next line and prints out 1. However, that is not the final step. Remember the important note of current methods being paused. Execution of mystery of 12, 123, and 1234 technically have not been done yet. So start from the bottom of the cup stack, which is mystery 1, the base case, and the bottom cup. That printed out 2 number 1s from the system print line before and after the if body. So we move on to the second cup, which is mystery of 12. We know that mystery of 12 prints out 2, so 2 is printed out. And we do that until we reach the most current method call, which is mystery of 1234. The final output is 43211234. Let's look at one more recursive example together. If I call check ladder, will it return true or false? Let's look at this code and make sure you remember precedents for logical operators. Ladder goes in the check method, and LADDER is 6 letters, which is greater than 2. Is L the same as A? It's not. So it calls check ADDER. This continues down until it reaches check DDER, which is 4 letters. Is D the same as D? It is, so the method returns true. And actually, the method returns true if and only if string S contains 2 or more of the same characters that are next to each other. Some common mistakes when doing Java recursion is missing the recursive call, so be sure to look for a call to the same method. Sometimes it's also confusing when and what a recursive method returns, and also just assuming you understand what the recursion is doing but not tracking all of it. So that's all there is. I hope you all enjoyed this video.
Created using Powtoon.